There's enough wealth floating between Mars and Jupiter to give every person on Earth $100 billion. Not million, billion, with a B. Enough gold to collapse the global banking system overnight. Enough platinum to power every car on the planet for 1,000 years. Enough iron to build a skyscraper for every human being who has ever lived. And we are just now figuring out how to go get it. Neil deGrasse Tyson once famously said,
"The first trillionaires will be those who mine asteroids."
He was right, but there is a catch. While Elon Musk might beat everyone to the $1 trillion mark, that is just a number on a screen. That is trillions on paper, a valuation that can vanish with a single market crash. The real trillionaires, the ones who will reshape history, will hold their wealth in mountains of metal. Their assets won't be lines of code. They will be solid iron cores the size of Massachusetts floating in the black. That person is alive today. They might be watching this video right now. This is the story of the greatest treasure hunt in human history, a gold rush that makes California look like a lemonade stand, a resource boom that will define the next century of human civilization. Welcome to the asteroid belt. Welcome to the Age of Trillionaires. For billions of years, they've been up there. Silent, invisible, drifting in the darkness between Mars and Jupiter. The ancient Greeks never saw them. Galileo's telescope missed them entirely. Even when we finally spotted them in the 1800s, we dismissed them as vermin of the skies, cosmic garbage cluttering up our view of the real planets. We called it the asteroid belt, a graveyard. The shattered remains of a planet that never quite formed. Dead rock, space debris, worthless. Every single astronomy textbook got it wrong. We weren't looking at a graveyard. We were looking at Fort Knox, floating 300 million miles above our heads. Let me put this in perspective. Remember when everyone lost their minds over Bitcoin? When a digital currency nobody could see or touch became worth trillions? People became millionaires overnight. The media couldn't stop talking about it. The asteroid belt makes Bitcoin look like monopoly money. We're talking about physical, tangible resources, mountains of platinum, oceans of frozen water, cores of pure metal the size of cities, not speculation, not digital tokens. Real materials that we desperately need and are running out of on Earth. Let's talk numbers, real numbers. Numbers so big they break your brain. Take asteroid 16, Psyche, 220 kilometers wide, roughly the distance from New York to Philadelphia. Scientists believe it's the exposed metallic core of an ancient protoplanet, stripped naked by billions of years of collisions. When we point our instruments at Psyche, we see iron, nickel, gold, platinum. The valuation? $10 quintillion. Write that down. A 1 followed by 19 zeros. 10,000 quadrillion dollars. That's enough to give every person on Earth $1.5 trillion. That's more than 100,000 times the entire global economy. And Psyche isn't even the most valuable asteroid we've found. That honor belongs to 511 Davida, a carbonaceous giant valued at $27 quintillion, nearly 3 times Psyche's worth. Why? Because Davida has something even more valuable than gold in space: water. Millions upon millions of tons of frozen water locked away in its carbon-rich interior. On Earth, water is cheap. Turn on your tap and there it is. But in space, water is liquid gold.
Water in space costs $10,000 a pound.
It's drinking water. It's breathable oxygen. It's rocket fuel. Split it into hydrogen and oxygen and you've got propellant. Right now, it costs about $2,000 to launch a single kilogram into space. Want to send a liter of water to the International Space Station? That'll be $2,000. A swimming pool's worth $50 million. But if you can harvest water from an asteroid that's already in space, suddenly deep space missions become affordable, refueling stations become possible, Mars colonies become practical. Psyche provides the steel to build the ship, Davida provides the fuel to fly it. But here's where it gets really interesting. We don't have to travel all the way to the main belt to strike it rich. There are asteroids in our neighborhood, near-Earth objects that have drifted out of the belt and now orbit close to our planet. Much easier to reach, much cheaper to mine. In July 2015, an asteroid designated 2011 UW158 zipped past Earth at about 6 times the distance to the Moon. Scientists analyzed its composition and discovered it contained 90 million tons of platinum. 90 million tons! At current platinum prices, that single asteroid was worth $5.4 trillion. More than Apple, Microsoft, and Google combined. Then there's 1986 DA. Spectroscopic analysis shows it's 85% metal, iron, nickel, cobalt, and platinum group metals. The iron alone exceeds all known reserves on Earth. Or asteroid 2016 ED85, another metallic near-Earth object, packed with precious metals. These aren't distant dreams, these are accessible targets. Companies like AstroForge are planning missions to these asteroids right now, not in 50 years, not in 20 years, right now. The business model is simple. Send a robotic spacecraft to a small, metal-rich asteroid, extract 1 to 2 tons of platinum group metals, return them to Earth. At rhodium prices of $200,000 per kilogram, that's $70 to $140 million in revenue from a single mission. Do that once, you've proved the concept. Do it twice, you've got a business. Do it 100 times, you're a trillionaire. But how do we know which asteroids are worth mining? How do we tell the difference between a $1 trillion jackpot and a worthless pile of gravel? Until recently, we didn't. Our map of the asteroid belt was blurry. We knew the giants like Ceres and Vesta, but the millions of smaller objects remained hidden in the noise. That changed in June 2025. High in the Chilean Andes, at an altitude where the air is impossibly thin and the stars burn like diamonds, the Vera C. Rubin Observatory opened its eye for the first time. This isn't just another telescope. The Rubin Observatory houses the largest digital camera ever built, 3.2 billion pixels. It captures images so detailed you'd need 378 4K television screens to display a single frame. Its mission, the Legacy Survey of Space and Time, a 10-year project to map every moving object in the solar system. In its very first observation run, just 10 hours of total observation time spread across 7 nights in April and May, the Rubin Observatory detected 2,104 new asteroids. 2,000 in 10 hours! Imagine walking into a dark warehouse and flipping on the lights. Suddenly, the empty space is crowded with treasures. That's what happened. Near-Earth asteroids, Jupiter Trojans, trans-Neptunian objects, objects that have been orbiting the Sun for 4.5 billion years, suddenly visible for the first time. But it wasn't just the quantity that shocked scientists, it was what those asteroids were doing. For decades, scientists believed that large asteroids were rubble piles, loose collections of boulders and dust barely held together by weak gravity, like a bag of gravel floating in space. Physics sets a speed limit for rubble piles. If you spin them too fast, centrifugal force overpowers gravity and they fly apart. That speed limit, called the spin barrier, is about 2.2 hours per rotation. Spin faster than that, the asteroid tears itself to pieces. Or so we thought. The Rubin data revealed 19 asteroids that shatter this rule. Large objects, some over 700 meters wide, spinning far faster than they should be able to. The most extreme example, 2025 MN45, 710 meters in diameter, longer than 6 football fields, completing a full rotation every 113 seconds. That's not a typo. 113 seconds. This mountain-sized rock spins completely around 32 times faster than it should. It should have exploded billions of years ago. The fact that it hasn't means one thing: it's not a rubble pile. It's solid rock, a monolith, a single cohesive body with tensile strength comparable to granite. And for the mining companies watching from Earth, this changes everything. Try to mine a rubble pile and your drill just pushes you away. Try to land on it and you might sink into loose gravel. Try to anchor equipment and the whole thing might come apart. But a solid monolith? That's a foundation. That's something you can bolt machinery to. That's a stable platform for industrial operations. The Rubin Observatory didn't just find asteroids, it found construction sites, mining platforms, the addresses for the gold rush. And this is just the beginning. As the legacy survey continues over the next 10 years, scientists expect to catalog over 10 million asteroids, every single economically viable target in the inner solar system. For the first time in history, we have a treasure map, a comprehensive ledger of industrial assets floating in space. The geography of the asteroid belt is no longer a mystery, it's a business plan. James Marshall is building a sawmill on the American River in California. He spots something glinting in the water: gold. Within a year, 300,000 people had descended on California, ships abandoned in San Francisco harbor as their crews deserted for the gold fields, tent cities springing up overnight, fortunes made and lost in a single season. The California gold rush transformed America. It accelerated westward expansion. It built cities. It created millionaires from farmers and bankrupted aristocrats. It was chaotic, lawless, and absolutely electric. Now multiply that by 1 million and set it in space. The new prospectors don't wear boots and carry pickaxes. They wear suits and carry PowerPoint presentations. Companies like AstroForge, founded by former SpaceX engineers, are building spacecraft specifically designed to mine asteroids for platinum group metals. Their first mission launched in February 2025. They're not messing around. TransAstra Corporation has developed something called optical mining, using focused sunlight to literally bake water out of asteroids. They've secured contracts with NASA and the US Space Force. Planetary Resources, Deep Space Industries, Origin Space, dozens of startups funded by venture capital and backed by billionaires who see the asteroid belt as the next Amazon or Apple. These aren't dreamers, these are engineers with rocket scientists on staff and $100 million budgets. And behind them, the real money is mobilizing. Every January, the world's elite gather in the Swiss Alps for the World Economic Forum. Billionaires, heads of state, the people who actually run the global economy. In January 2026, asteroid mining dominated the conversation. The theme was a spirit of dialogue, but in the closed-door sessions and hallway conversations, everyone was talking about one thing: the orbital economy. McKinsey and the World Economic Forum released a joint projection. The global space economy will reach $1.8 trillion by 2035. Not might, will. This isn't satellites and GPS anymore. This is space-enabled industrial services, mining, manufacturing, resource extraction on an industrial scale. Sessions like Beyond Earth, the Next Space Race discussed how the orbital economy would redefine global supply chains, not supplement them, not enhance them, redefine them. The new financial order panel discussed how private capital is now funding deep space ventures that used to be the exclusive domain of national space agencies. SpaceX can launch rockets cheaper than NASA. Blue Origin is building orbital habitats. Private companies are doing what governments once monopolized. And here's where it gets really interesting: space sponsorship. Think about it. When the first mining mission successfully extracts platinum from an asteroid and returns it to Earth, that's not just a business milestone, that's a global spectacle. Billions of people watching, historic footage that will be replayed for centuries. That attention is worth money, serious money. Companies are already viewing space missions as marketing platforms, similar to how sports became a $2 trillion industry. Brand partnerships, sponsorship deals, exclusive rights to historic moments. A mission might cost $300 million, but if it generates $50 million in sponsorship revenue and commands global attention for 6 months, suddenly the economics shift. Space isn't just industry. Space is entertainment. Space is marketing. Space is the ultimate billboard. So let's ask the obvious question: who's going to be the first trillionaire? It won't be someone who just mines one asteroid. The market couldn't absorb that much material at once. Flood Earth with platinum and the price collapses. No, the first trillionaire will be the person who builds the infrastructure, the one who figures out how to make asteroid mining routine, repeatable, scalable. They'll own the supply chain, the refining process, the transportation network. They'll control access to resources that everyone else needs. Think about it like the California gold rush. Most miners went broke, but the people who sold picks and shovels, they got rich. The people who owned the shipping companies, they got rich. The people who built the railroads, they got filthy rich. The first trillionaire won't just mine asteroids, they'll build the infrastructure that makes asteroid mining possible for everyone else, and they'll take a cut of every single operation.
Right now, Elon Musk's SpaceX and Jeff Bezos's Blue Origin are well positioned to be the infrastructure builders by providing relatively cheap access to space with reusable rockets, much like the railroad operators of the 19th century.
But there's a problem, a big one. Who owns the asteroids? The 1967 Outer Space Treaty says space belongs to all humanity. It's the common heritage of mankind. You can't plant a flag and claim the moon. You can't declare sovereignty over Mars. But what about resources? If you send a robot to an asteroid, extract some platinum, and bring it back to Earth, is that yours? The Outer Space Treaty doesn't really say. Enter the Artemis Accords, championed by the United States and signed by multiple nations. The accords allow for safety zones around mining operations. They permit the extraction and ownership of resources. It's a clever workaround. We're not claiming the asteroid, we're just claiming what we extract from it, and establishing a safety zone to prevent interference. Critics call it colonialism with extra steps. If you land on Psyche and declare a 50-kilometer safety zone around your operation, you've effectively annexed the territory. Try to mine the same area? Sorry, safety violation. China and Russia haven't signed the Artemis Accords. They're developing their own frameworks, their own rules. We're watching the birth of space law in real time. And it's messy, contradictory, potentially dangerous. What happens when two companies claim the same asteroid? What happens when a Chinese mining operation and an American mining operation both want Psyche? What happens when someone's safety zone blocks another company's trajectory? These aren't hypothetical questions. They're scenarios that lawyers and military strategists are gaming out right now. The first space gold rush might not be settled in boardrooms. It might be settled by whoever gets there first and refuses to leave. Possession is 9/10 of the law, even in space. Okay, so we've established that there's unimaginable wealth floating in the asteroid belt. We've identified specific targets. We've got companies willing to try. Now comes the hard part. How do you actually mine a rock floating in space? On Earth, mining is brutal but straightforward. Gravity is your friend. You dig a hole and the ore falls down. You crush rock and the heavy metals sink to the bottom. You build structures and they stay put. In space, gravity is your enemy, or rather the lack of it. You can't dig a hole in an asteroid. There's no down for the material to fall into. Hit a rock with a hammer and you don't break the rock, you push yourself backward. Try to drill and the drill bit just spins you in circles. Everything we know about mining, everything we've learned over thousands of years of digging into the Earth, is useless in space. We had to start over, reinvent mining from first principles. TransAstra Corporation came up with something brilliantly simple. Don't touch the rock. Burn it. Their system uses enormous inflatable mirrors, giant magnifying glasses made of ultra-thin reflective foil. These mirrors focus raw sunlight onto the asteroid's surface, concentrating solar energy until the rock heats to 3,500 degrees Fahrenheit. At that temperature, something remarkable happens. The surface doesn't just melt, it fractures. Thermal shock causes the rock to spall, to crack and pop off in chunks, like popcorn in the microwave. More importantly, the intense heat drives water and other volatile compounds out of the rock as steam. The asteroid literally sweats its internal water reserves. But you can't let that steam escape. It's the whole point of the operation. So they bag the asteroid. Seriously, they enclose the entire body in a giant inflatable capture bag made of high-temperature fabric. The bag traps the debris and the water vapor, preventing anything from floating away into space where it becomes hazardous debris. Inside the bag, cryogenic pumps freeze the water vapor and collect it. TransAstra's APIS mission, asteroid-provided in-situ supplies, aims to harvest 100 metric tons of water from one near-Earth asteroid using just one Falcon 9 launch. 100 tons of water in space, where every liter is worth its weight in gold. And here's the genius part. They use that water as rocket fuel. TransAstra's Worker Bee space tugs run on a solar thermal engine called the Omnivore. Heat water with concentrated sunlight and it produces thrust. Mine an asteroid for water, use that water to fuel your spacecraft, fly to another asteroid. Repeat. It's a closed loop, self-sustaining, no refueling from Earth required. The asteroid belt becomes its own economy. While TransAstra chases water, AstroForge is after something more valuable: platinum group metals. Their approach is equally clever. They exploit basic physics. Iron and nickel are ferromagnetic. Platinum, gold, and other precious metals are not. AstroForge's mining spacecraft lands on a metallic asteroid using magnetic clamps that grip the iron-rich surface. Once anchored, they deploy a dual laser system. The first laser melts the surface material into a liquid. The second laser, essentially a high-powered pulse, acts as a hammer, splashing the molten material upward where robotic collectors capture it. This molten material is then fed into an all-electric refinery. Inside, the metals are vaporized. Then comes the separation. Powerful electromagnets pull the ferromagnetic iron and nickel away from the non-magnetic platinum group metals. The iron gets ejected as waste. In space, you can afford to be picky.
The platinum is collected, cooled, and packed into heat-shielded re-entry capsules lined with mylar. Each capsule might contain only a few hundred kilograms, but at rhodium prices of $200,000 per kilogram, you're looking at tens of millions of dollars per payload. Drop it into the ocean, send a ship to tow it in, sell the refined metal, fund the next mission. It's not science fiction. AstroForge's first spacecraft, Odin, launched in February 2025. Their follow-up mission, Vestri, is scheduled for later this year. These are commercial operations, for-profit ventures. They're not publishing papers, they're selling platinum. But who's doing the actual work? Who's operating the lasers and collecting the materials and flying the spacecraft? Not humans. Not yet. The asteroid belt is 300 miles from Earth. Radio signals take 12 to 48 minutes to travel one way. You can't remote control a robot with a 96-minute communication delay. The robots have to think for themselves. Modern AI systems can navigate autonomously for months without human intervention. They use laser spectroscopy to identify metal-rich zones. They adjust mining parameters based on real-time feedback. They coordinate with other robots in swarm formations. And they do it all without sleep, without food, without life support, without demanding to come home. The workforce of the space gold rush is silicon and steel. Swarms of autonomous mining robots that operate 24/7, continuously extracting and refining materials. If one robot fails, the swarm adapts, the mission continues. It's a redundant, relentless industrial organism designed to eat rock and excrete value. This is why asteroid mining is becoming economically viable. Human labor in space is impossibly expensive. Every astronaut needs life support, radiation shielding, food, water, psychological support. The logistics of maintaining even a small crew at asteroid mining operations would consume most of the budget. But robots? Launch them once, let them work for years. The integration of AI and robotics isn't a luxury feature for asteroid mining, it's the entire business model. So, where does this all lead? What does the world look like when asteroid mining is routine? Let's fast forward to 2050. NASA's Psyche mission completed its survey in 2031. The data confirmed what spectroscopy suggested. Psyche is indeed a metallic core rich in iron, nickel, and platinum group metals. The valuations weren't exaggerated. Based on that data, multiple companies established permanent mining operations on M-type asteroids throughout the belt. Not just Psyche, dozens of smaller metallic bodies that are easier to reach and process. TransAstra's optical mining platforms have harvested tens of thousands of tons of water, establishing a network of propellant depots across the inner solar system. Worker bee tugs ferry cargo between Earth orbit, the Moon, Mars, and the asteroid belt, refueling at asteroid waypoints. The cost of deep space operations has plummeted. What used to cost billions now costs millions. What was impossible is now routine. AstroForge and its competitors have successfully returned hundreds of tons of refined platinum group metals to Earth. The initial impact on precious metal markets was dramatic. Prices dropped by 30%, but the market absorbed the new supply. Industries that couldn't afford platinum before now use it liberally. Fuel cell vehicles become economically viable. New types of electronics emerge. Orbital manufacturing facilities, built partially from asteroid materials, produce spacecraft components and solar arrays in microgravity. These facilities employ hundreds of workers, yes, actual humans now, living in rotating habitats that provide artificial gravity. The first major orbital city is under construction, built inside a hollowed-out carbonaceous asteroid. It's not complete yet, but its skeletal framework is visible from Earth through telescopes.
a city in space, powered by asteroid resources. And on Earth itself, something remarkable has happened. We've started to heal. For 10,000 years, every human civilization has been constrained by one brutal fact. All our resources come from Earth. Want copper for electrical wiring? Dig a pit mine that scars the landscape for centuries. Want platinum for catalytic converters? Process tons of ore using toxic chemicals that poison groundwater. Want rare earth elements for electronics? Create environmental disasters that locals will suffer from for generations. Mining on Earth is ugly, necessary but ugly. Toxic chemicals, air pollution, water contamination, destroyed landscapes. But by 2050, we're starting to transition. The dirtiest mining operations, the ones extracting the rarest and most valuable materials, are shutting down. Not because of environmental regulations, because it's cheaper to mine in space. No environmental impact reports needed in the asteroid belt. No protests from local communities. No concerns about groundwater contamination. Mine an asteroid, and the only thing you're disturbing is empty space. Landscapes ravaged by centuries of mining begin to heal. Rivers run clean again. The toxic tailings ponds get remediated. And the price of advanced technology drops. Platinum group metals become commodity materials instead of precious ones. Electronics get cheaper. Clean energy becomes more affordable. The technological wonders we've come to depend on cost less and harm the environment less. This is the promise that drives the space gold rush. Not just wealth, though there will be obscene wealth. Not just exploration, though there will be incredible discoveries, but the possibility of decoupling human industrial growth from Earth's biosphere. For the first time in history, our civilization's expansion doesn't have to destroy the planet we live on.
But let's be honest about something. This vision, this beautiful future where we've solved resource scarcity and saved the environment, it's not guaranteed. Technical failures could doom early missions. Space is unforgiving. A single miscalculation, one failed system, and millions of dollars worth of equipment becomes expensive debris. Economic shifts could undermine the business case. If some breakthrough in materials science suddenly makes platinum abundant on Earth, the value proposition collapses. Political conflicts could militarize space. If nations decide that control of high-value asteroids is a national security imperative, we could see weapons platforms, contested claims, even military conflicts in orbit. And there's always the risk of unintended consequences. What happens when an AI mining system encounters a scenario its programmers never anticipated? What happens when mining debris damages Earth observation satellites? What happens when the first trillionaires control resources equivalent to entire nations? These aren't arguments against proceeding. They're arguments for proceeding carefully, thoughtfully, with international cooperation and robust safety protocols. The asteroid belt has been there for 4.5 billion years. It'll be there for another 4.5 billion. We have time to get this right. But here's the thing. We're going to do it anyway, because that's what humans do. We see treasure and we chase it. We see a frontier and we explore it. We see the impossible and we make it possible. The California gold rush happened despite terrible odds and tremendous suffering. People died, most went broke, but California got built. The space gold rush will happen despite the technical challenges and the political complications. Some missions will fail, some companies will go bankrupt, but the infrastructure will get built. Because the prize isn't just money. The prize is options, freedom from limits, a future where human potential isn't constrained by the resource budget of a single planet. We're living through something extraordinary, a pivot point in human history that most people don't realize is happening. For all of human existence, wealth meant control of territory on Earth,
land, resources, trade routes. Everything valuable was here on this rock, and if you wanted it, you had to take it from someone else. Every war in history, every empire that rose and fell, every political boundary on every map, it's all about who controls which patch of dirt and what's underneath it. That era is ending. There's a whole solar system out there, unlimited resources, unlimited room to grow, unlimited possibilities. And we're finally developing the technology to reach it. In boardrooms and university labs and mission control centers, the conversation has shifted. Nobody's asking if anymore. Everyone's asking when and how much. So let's come back to where we started. The first trillionaire. They're out there, alive today. Maybe watching this video, maybe lying awake at night right now, staring at the ceiling, planning their next move. They're probably an engineer, someone who understands the technical challenges intimately, someone who's worked in aerospace or robotics or AI. They're definitely an entrepreneur, someone willing to bet everything on a vision that most people think is crazy, someone comfortable with enormous risk. They're absolutely obsessed. You don't become the first trillionaire by working 9 to 5. You do it by dedicating every waking hour to a singular goal that consumes you. And they're probably not who you think. More likely, it's someone most people have never heard of. A founder of a startup that's barely making news today, but will dominate the headlines in 10 years. The first trillionaire won't just be rich, they'll be the architect of humanity's future beyond Earth, the person who proved it could be done, the one who opened the door for everyone else. They'll be the person who took the first real step toward making humanity a multi-planetary spacefaring civilization. The treasure map is complete, the technology exists, the capital is flowing, the race has begun. The first space gold rush isn't coming, it's here.